Thanks for joining me for this talk on the building blocks of security lifecycle management. My name is James Baer. I lead our product management function at HashiCorp. When talking about building blocks of a security program, I think it's really essential to think about things holistically. And no one does this better than the National Institute of Standards and Technology. So NIST created the Cybersecurity Framework 2.0. It's a major revision of the framework that they announced this year, at the beginning of the year. And new to this year is this governance aspect. And so if we build this out a little bit, the identify, protect, detect, respond, recover aspects have been a part of this framework since it was introduced. But something that you'll see later on as a theme of this talk, we really believe in teamwork, and what Armand was referring to earlier is that you don't just want your security team in a silo to say security is just the security team's responsibility. You really need to incorporate security throughout your organization. And so when you look at building blocks, there's no better place. So please take a look at this, because we're going to focus in on where HashiCorp really applies, which is really around the identify, protect, and detect parts of this lifecycle. But there's other aspects of this that you should look at as well. All right, so now I want to talk a little bit about a real-world examples of what's going on in the industry, because I think that's really important before we start talking about what our products do and what problems we're solving with that, to understand what's happening in the real world. And so I hope you like stories, because it's October and Halloween's coming up, and this is a little bit of a scary story. Why is that? Because I'm going to mention some things here that I think all of us could look at and say, oh boy, I think some of this could apply to us. So I'm talking about technologies like artificial intelligence, AI. That's something that's coming up a lot. Kubernetes, Argo CD, Istio, Docker, AWS. Does any of that sound familiar to you? If so, hold on. Let's talk a little bit about what's happening. So Wiz did this analysis of a real-world enterprise security. It's a SaaS service, and this organization wanted to make their data available to their customers to interact with AI. Sounds pretty fun, right? Well, unfortunately, they found some problems. And the good news is, even though this is a scary story, these were white hat hackers. Nobody was harmed in this. But I think it's a cautionary tale. So the first thing they did is that they made their SaaS data available through a Kubernetes cluster. And so you could package up your AI things into a container and give it to Argo CD, and they would run that on a Kubernetes cluster for you. And so the first thing that these white hat hackers found is that you could get a shell into that environment and probe around and see, well, there's a firewall. That firewall was implemented with Istio, and they were like, well, I wonder if we can break out of this firewall. And it turned out, yes, they could. Because they could instruct Argo CD to run their processes in the Istio sidecar, in that namespace. And then they could pretend to be the same user ID as Istio, because they'd say run as the same user ID. And that was enough to get them out of the firewall. OK, so that's step one. Now they are on the network, and they can see everything inside the Kubernetes cluster from a network perspective. The first thing they do is they probe the network, and they find an unauthenticated Helm server. And so from that unauthenticated Helm server, they could say, well, what's deployed with this Helm server? They found an instance of Loki. They found a whole bunch of file shares from AWS that were mounted onto that Kubernetes cluster. And then from there, they decided, like, well, what if I could tell Helm to run one of my containers? And they could end up doing that, and they could do that and ask Helm to do that with cluster admin privileges. Oops. That means now the hackers had full control over the entire Kubernetes cluster. And once you're running as cluster admin, it's pretty much game over. Because at this point, if you go look at the impact of how far they got the internal customer logs from the Loki service. They got customer data that were mounted in the file stores. They had access to all of the secrets and data that was in the Kubernetes cluster. And then from that data, they could see, like, those secrets gave them access to the Docker registries and the Artifactory instance that could allow them to upload and manage containers that were used by other Kubernetes clusters. So that you can see how they can even spread further, right? So hopefully you're a little scared, because if you're using Kubernetes, Docker, Argo CD, AI, and all these are things you really do need to think about, and it shows you how difficult it is to secure some of these things. But I want to talk a little bit about secrets now, because like, what are they doing with secrets, and what are some of the patterns? What can we learn from that? So here's an example of the Loki configuration. And you'll notice this is a standard configuration, except that they hard-coded the AWS secret directly in the Loki configuration. When you hard-code it directly in the configuration, it makes it very difficult to change, because someone has to remember to go update that configuration file. So hold on to this thought. We're going to come back to this later when we talk about what we can do about it. I'm going to zoom through a couple of other examples here. Here's them using those AWS credentials to list from the AWS CLI the files in those customer data stores. You know, again, these were white hat hackers. Thankfully, no one was really actually harmed in this. It was responsibly disclosed to this enterprise security vendor. But it just shows you how bad this can go. Here's an example of, again, listing some of the Helm configurations. You see hard-coded configuration passwords for the Docker registry in there. If we advance to the next slide, you'll see the cluster admin access. So this is using the kube control command line to list all of the different attributes of the Kubernetes cluster, so they can prove that they really did get cluster admin. And once you're cluster admin, you can actually directly list secrets. So here's an example of them listing secrets. And again, you can see Docker credentials and AWS access keys available. So that's not just the SaaS vendors' secrets. It's actually the secrets from their customers. So this represents an AWS key from one of their customers that they had put in that, right? So I was talking about a scary story. This is pretty scary stuff if you are a software vendor and you had this kind of breach. So thankfully, they were able to address all these problems. All right. Let's talk about a couple other real-world examples. That was one specific example with a bunch of technologies that many of us are probably using in our organizations. GitHub Actions. We heard earlier from Armon about how Radar is helping find secrets in source code. But it's not just your source code. It's also your CI/CD systems, where you might have secrets in your configurations. And in this example, a security researcher looked through a bunch of GitHub hosted software where they use GitHub Actions to build their artifacts for those particular pieces of software. And one of the very common things that people do with a GitHub action is clone a version of the repository directly into that GitHub action, so that action has the files to work with. Well, so if you've had secrets in your source code, that ends up going into this temporary directory for that GitHub action. And at HashiCorp, we make Go binaries with our software releases. But not all software releases are like that. Sometimes you actually package up the files that are in the GitHub repository. So in this case, some of these organizations had secrets that in those repos that were making it directly into their build artifacts. And so it's really important to not only think about your source code, but also your CI/CD systems, as well as your release artifacts that you're creating, to see if they have secrets as well. Snowflake was a great example earlier. There were multiple Snowflake customers that got some of their data taken from them. And what had happened in that case is they had employees and contractors that were not using single sign-on and were not using hardware-based multi-factor authentication. And so when you have that, you have these accounts, user accounts, that are completely separated from the lifecycle management that's typical of your organization. And so when you have that happen, it's just a static username and password. You're kind of relying on your employees and contractors to remember to change those things. Or what happens if the contractor ends their contract, but you don't have a good offboarding process? Then their username and password sticks around for a really long time. And so that's what had happened here. So you combine that factor with what happened next, which when you have employees and contractors, it's really important to have those machines be endpoint managed so that you have security policies and procedures there. But I've seen a lot of organizations, and this actually happened last year in the Okta breach, where there were contractors where they brought their own equipment to their employment, whether it was a contractor or even sometimes employers allow people to bring their own equipment. And so if you have that situation and there's no controls on those devices, they can download scary stuff from the internet They not know what that is, and that can have malware. And once you have the malware, they can harvest the credentials using keystroke logging or scanning on those machines. And once you have those credentials, you can get access to all of your customers in your organization's data in Snowflake, because that's some of the biggest sources of data you have. It's a data warehouse. You're putting all of your data from your organization, many of your customers' data into the system, and now the hackers had access to that, right? So thinking about how you can safely manage the data access is super important. Last scary story here, Orion, public company, had to file a $60 million charge with the Security and Exchange Commission. What happened there is one of their employees got tricked by getting an email with what appeared to be from someone like their CFO, asking them to make wire transfers. And if you think about that example plus similar examples where you hear about organization actually hiring North Korean hackers on accident because they're interviewing someone over Zoom, they send them a laptop, and then this security organization, like, well, this is strange. Why is that laptop being opened in North Korea? And why are they installing malware on it? It's because they got tricked, right? So it's really important to use hardware-based authentication from single sign-on sources when you're interacting and doing business. If someone's contacting you from an email or a phone number, even if they sound or look like the person, if they're not using something that's strongly authenticated against your SSO with MFA, you could get yourself in trouble. Okay, so these are some of the things that are going on in the world around us that we can feed back into what we're doing at HashiCorp to try and address some of these problems. And in particular, Mandiant, which is a part of Google, they looked at the Snowflake example and they gave the analysis that I kind of summarized. But one of the things they noted there is that credentials identified in this example were still valid years after they were stolen, right? So that's clearly a problem. You want to have a much more active policy than that. Second thing, at HashiCorp, we asked about 150 of our enterprise customers, and we asked them about their secrets management practices. And one of the questions was, how many of your what percentage do you think is actively managed by policy and actively rotated? And the answer we got back was only about a third. So if you think about that, it could be about 2/3, and maybe your organization is much better than this, but there's certainly unmanaged risk in your organization from secrets. And then if you zoom a little bit further back out, the Verizon Data Breach Report is one of my favorite sources of data every year. They publish an annual report. It looks at all the public breaches. They don't look at the private ones, so we can learn from the examples I was sharing earlier. And it gives you a kind of an indicator of where things are. But by far, the #1 source of the initial breach is credentials for web applications. And so if you really want to make an impact, if you focus in on that, you can really bring down the amount of risk you have. There are other places that you have risk. People can be phished. You can see that there are sometimes vulnerabilities in your software supply chain that people take advantage of, sometimes vulnerabilities in VPNs or screen sharing, those kinds of things. But by far, the most common vulnerability is from a web application credentials. Okay, so what are the lessons that we have taken away from this as well as talking to our customers? #1, we know it has to be easy. If it were easier, then maybe people actually would be rotating their credentials more often. They would be managing those more often. We've got to make it easy for people to do the secure thing. The second thing is, and I talked about this earlier when I talked about the governance aspect of, there you go. When I talked about the governance aspect of the NIST program, security is a team sport. You cannot just outsource all of this stuff and say it's the security team's responsibility. I'm a developer, I'm an operator, it's not my problem. Because it's just a mountain of work that they'll never get through, and they don't know where all the practices are every day, right? So you really need everybody to be participating here, and we need to make our HashiCorp products actually make that possible and help facilitate that teamwork. And the final lesson is about visibility. You can secure it if you know it's there. So can we help you find some of these things? So we're taking these 3 lessons and we've been applying that to our innovations that we've been making in our roadmaps. So Armand talked a little bit about this. How does this realize in HashiCorp products? We talk about it as a security lifecycle management portfolio or a suite of products. We have Vault, which is helping machine-to-machine identities and credentials. We have Boundary for when people need to access privileged systems and making that as simple and straightforward as possible. And we have Consul for doing the connections between machine to machine and making sure that transport connection can be secured. And when you bring all that together, we've been focusing a lot more on the day 2, day 3, day 4 parts of this life cycle. Day 1 is certainly important, but we've been making a lot of investments to make sure that a lot of the ongoing challenges that have been surfaced from talking with customers can be addressed. So the mantra that we've been using over the last couple of years has been all of your secrets automatically rotated, easy compliance. Now we're not all the way there yet, but this is our North Star because we believe if we can pull this off, it's going to have a massive impact to address all those things that we were talking about earlier that are scary stories, right? So let's talk about some of the specifics. We've been using this inverted triangle to talk about the different parts of the security, in particular secrets portfolio. So you have your unmanaged secrets at the top. So these are I said earlier, for our 150 enterprise customers we surveyed, about 2/3 of their secrets were unmanaged. How can we help you with those? And now with Radar, we have a great answer for that. With your vaulted secrets, you can store them, you can make sure they're access controlled, but then we've still put the responsibility for rotating and lifecycle managing those secrets on a person. And we want to make sure that we can keep going down this triangle so that we can use automatically rotated secrets and dynamic secrets that are short for a very minimal amount of time. So as an example, the dynamic secret, if you're only using it for your CI/CD build, as soon as that CI/CD build is done, the secret doesn't have to be lifecycle managed anymore because it's going to expire and it's not going to be useful anymore. Same thing for when you access a break glass scenario in a production system for troubleshooting. Make that secret live for only the lifetime of that troubleshooting session, and when that's over, the secret is done. That is really easy because you don't have to remember to clean anything up afterwards after that. I'm going to zoom in a little bit later on rotated secrets because that's something I believe is new innovation that is going to really help. So first, let's talk about those unmanaged secrets. So with Radar, we acquired this company about a year ago, and it's really exciting because it can find your unmanaged secrets in source code, and we've also introduced the capability for it to find secrets in other kinds of systems. So things like Atlassian Jira or Atlassian Confluence. We can also scan other things like file systems and Docker images. So if you think of something like Terraform, which has this large ecosystem of providers, we are certainly trying to replicate that with our ecosystem with Radar, and we're starting to make good progress on that as well. Armand talked a little bit about this hybrid architecture where we now have a Radar agent that can run in your environments, and so the scans can happen locally. Your secrets never leave your network and your environments, but we do get a hash and metadata of that to make sure you can manage and work through those findings really easily. We've also been working on shift left. So Armand talked about making sure that secrets don't get into your source code in the first place, but also when you submit pull requests, when you look at secrets that might already exist in your source code, we have answers for each parts of those. And then the ability to provide that custom remediation guidance. So your security team can specify the guidance that makes sense for you, whether that's directing them to some kind of self-service portal to get access to Vault, or telling them who they need to contact. They can take on some of that relationship themselves. So if you remember that lesson about security being a team sport, this doesn't become like a list of 5,000 findings that the security team has to deal with. They can help spread this responsibility to the development teams that are responsible for those source code. As I mentioned, we just added Atlassian, Confluence, and Jira, so we're really excited to expand the ecosystem with Radar. So please give it a try. It's live on cloud.hashicorp.com. It's public beta. We're not charging during the public beta, so anybody can get on there and try it today. All right, so now I want to talk about HCP Vault secrets. We've made this extraordinarily simple. I remember that first lesson is make it easy. Some of the feedback we've gotten from customers is we really want to make it easy for all of our end users, not just our security experts. And so we've really been focused on that with HCP Vault secrets. So we introduced resource level access control to really have fine-grained access for just the specific applications for the right people. Audit log streaming to make sure these activities that are happening with your secrets are being able to stream to your sources like Splunk or whatever kind of logging system you use. And we've packaged it for enterprises to make it easily consumed. There are no clusters to configure in this product. That was one of the feedbacks we got is like, setting up a cluster can be hard and configuring that. You just say new application, new secret, and you're off and running. So you can get started in just a few moments. One of the innovations we came up with was grouping secrets by application, because with the traditional Vault, the secrets were, you'd have to remember secret 1, secret 2, all the way to secret 15, and ask for those individually. It's a lot easier for developers if they just have a foo application. They say, give me all of the secrets associated with my foo application all at once, whether those are dynamic secrets, rotated secrets, or static secrets. You can bring them all back at once. So people really like that capability. The second thing I want to talk through about this is this new auto-rotating secret. So let's give an example of a 60-day rotation policy. On day 0, we're going to create version 1 of this secret. And then on day 30, halfway through the rotation period, we're going to create version 2. And so what would normally happen as we approach day 60, we're going to create version 3 of that secret, and automatically, at the end of that, version 3 is created, remove version 1 of that secret. So as a consumer of this, all you have to do is use your organization's restart policy. Let's say I need to do patching every 30 days anyway, so I might as well take advantage of that and make sure that when my applications restart, they're automatically using version 2 of that software. And so by doing that, they don't even have to think about rotating themselves because Vault's taking care of that for them. And if you think about another example of this, what happens if I accidentally leak a secret and I want to advance the rotation so that it happens immediately? So on day 61, we might have leaked a secret to a log. We can make sure all the applications are now on version 3 of that secret, and we can then revoke the version 2. What would happen then is we'll know that since we rotated on day 61, we won't need to rotate again until day 91. I'll create version 5 and rotate version 3 and so on. I think of this a little bit like how I set up auto bill pay. Who wants to remember to get the notice from their cable company or telephone company and write the check out every month and make that payment, right? You want to set up auto pay. Well, this is kind of like distributing that load. My responsibility when I set up auto pay is make sure I have enough money in my bank account to do the payment, right? So the responsibility on developers here is make sure you restart your application at least once in that rotation period, so in this case every 30 days, and you'll always have to pick up the latest copy of the secret, and you never have to worry about rotation again. So remember Loki from earlier in our talk about that enterprise SaaS vendor, that they had hard-coded the secrets? So let's think about applying this auto-rotating secret capability to Loki. So you can just ask Gemini or any of your favorite AI chat agents, hey, can I give dynamic secrets to Loki with environment variables? And absolutely you can. And so we can take this learning and now use something like this very simple command line, which will pull down the secrets for my Loki application, which would include the AWS environment variables, and it can just be that simple. If I'm running this as a Kubernetes workload, we have a Vault Secrets operator which manages that for you, and so you can just start your Loki YAML file as normal. Those secrets will be provided as environment variables, and you don't have to think about that rotation. So if you go think about that earlier example about that enterprise SaaS vendor that had hard-coded their secrets, you don't have to do that. You can do something as simple as this and take care of that. So my belief is that this is the absolute easy way to get automated rotation spread throughout your entire organization, because all you have to think about is restarting your instances on a schedule. If you do that, you're going to get automated rotation. So that'll happen automatically. If you want to advance the rotation because you had a leak or you want to just make it happen sooner, you have to restart your apps and then click rotate now and you're done. We've been working on a lot of other capabilities that keep getting better as well. So auto rotation works with secret sync. So when we take secrets out of Vault and put them in other places like the cloud native secret solutions like AWS Secrets Manager, Azure Key Vault, GCP Secret Manager, GitHub Secrets, Vercel Secrets. These are things that as soon as they're rotated in Vault, we will push the secret out to those locations. And if your developers prefer to receive, like if they're writing a GitHub action, to just use a GitHub secret instead, they don't have to be even aware that Vault's there behind the scenes rotating the secret. It's really capable for your security teams get the rotation policies they want, your developers get to use GitHub secrets and the simplicity and not having to know about Vault. Everybody wins. So I mentioned Kubernetes earlier when we were talking about all those examples. I believe we have the absolute best Kubernetes solution on the market for managing secrets there. Kubernetes secrets are not versioned themselves. They are static key value entries. And with Vault, you can supercharge your Kubernetes secrets, make sure that they're securely rotated, managed by Vault, and get versioning and all kinds of other capabilities that aren't in native Kubernetes. So please take a look at the Vault Secrets Operator. It's something that our customers are really enjoying and getting a lot of benefits from. We talked about boundary transparent sessions, and remember one of those lessons earlier about making it easy to use in order for the secure practices to be adopted. What could be easier than not having to learn that you have to use boundary because it's just there in the background and works when you type SSH, right? So transparent sessions is that simple, and it's really something that you have to see to experience how seamless it can be. So please give that a look. We're really excited about this capability. Wherever you have SSH or VPNs or Bastion hosts or other things that your developers complain about to do troubleshooting in production, we believe this is a much, much better way. And finally, I want to talk about certificate management. So certificate management is a lot like managing a secret, except it's a special kind of secret with a certificate of authority and things like that. Vault can treat your certificates a lot like these rotated secrets. So in a traditional way, you might put your developers into the position of having to type OpenSSL commands and very low-level things to create a certificate signing request. They do this maybe once every 2 years or something, right? So something very rarely done. People might forget. And so if we start treating our certificate lifecycle management, like SAP told us earlier, they're issuing thousands of certificates an hour, I believe. You can treat your certificates a lot like a short-lived secret and have Vault be doing that all the time. And so with this, we've all probably experienced this situation where you've gone to a place that the system's down because their certificate expired. Well, don't have that problem anymore. Just have that be something you're doing all the time in the background, and that way you're automating that problem away. So we have a couple other announcements we talked a little bit about throughout the day with Vault 1.18, so please check out some of the sessions later. Really excited about the new DNS capability in Consul 1.20, as well as some of the new cloud platform features for managing role-based access control and the audit log streaming. I hope you enjoyed today, and please stick around for some of the other talks. Thanks so much.